Hi, everybody. Welcome to this video for Math 60 on section 2.5, which is called point slope form for linear equations. So we've been talking mostly about, and it still makes sense to mostly use slope-intercept form. The general one of that is y equals mx plus b. And in order to have the slope-intercept form, you need to know the slope and a very specific point, you need to know the y-intercept. So if I tell you I have y equals 3x minus 4, you know the slope is 3 and the y-intercept is 4, and that would allow us to graph it. One, two, three, 4, and then every time you increase x by 1, you go up by 3, and every time x goes back, you go down, so you get something like this. Slope-intercept form is the way to go. If you can use it, you should use it. The issue is you can only use it if you know the y-intercept. And sometimes the y-intercept is the initial value, and sometimes you don't know the initial value, so you don't know the y-intercept. So how do you graph a linear equation? If you know the slope, but not the initial value, not the y-intercept. Let's do an example. I have some linear equation. The slope is -2, but I don't know the y-intercept. However, I do know another point. And the point 3, 4 is on the line. So how do you graph? How do you graph a linear equation if you know the slope but not the initial value? You need another point. The truth is you don't need the y-intercept. You just need any point. And the process is very similar to when you do know the y-intercept. If I knew the y-intercept, I'd start with that point. But since I don't, I just start with a point that I know, which is 3, 4. And I still know the slope, which means every time x goes up by 1, y goes down by 2. And so I can still graph my line. I don't ever, in fact, in this example, visually, I never know what my y-intercept is, but I do know a point that's on the graph. And so I simply start at that point, and then I use the slope to draw my line. Let's do another example. Let's say that my line has a slope of -1/3 and the point -1, 5. So if I want to graph it, I draw my axes. I don't know the y-intercept, but that's okay, because I do know that the point -1, 5 is on my graph. And then I use my slope to figure out another point. This says when x goes up by 3, y goes down by 1. So I count 1, 2, 3, and y goes down by 1. And then I go 1, 2, 3 again, and y goes down again, and I'm still able to draw my line. I definitely have a y. My function has a y-intercept. My line has a y-intercept. I don't actually know what that is, but that's okay. You don't need to know the y-intercept to draw the line. You just need to know the slope and one other point. Now, how do we write this as a formula? We can write the point slope with my x and y, but instead of y equals mx plus b, I don't know b, so I can't write it that way. Instead, I say y is the slope times x minus that first, call it x0. What I do is I write y equals a slope, and then I open a parentheses, and I take my variable x, and I subtract off the coordinate point x, and I call that x0. And then when I'm done with that calculation, I add in the coordinate point y0. So let me show you how this works with our line has a slope -1/3 and a point -1, 5. So my slope m is -1/3, and my point x0, y0 is -1, 5. So my point slope formula is the variable y equals -1/3, which is my slope. And then I take my variable x minus the -1, and then I add the 5. And we often write the minus and -1 as x plus 1. And then we add 5. But I'm fine with either of these formulations. You take your slope, you multiply it by x minus your x coordinate, and then you add your y coordinate. And this graph right here will produce, or this equation right here will produce the exact same graph that I made when I graphed it by hand first. All right, let's do this using a word question. So let's see. Well, it tends to be easiest with money. So if I charge $10 a pizza, I sell 100 pizzas. If I raise the price by $2, I sell 5 fewer pizzas. So this word question contains a slope and a point. The slope is the change in output divided by the change in input, which in this case is the change in the number of pizzas divided by the change in price, because I decide the price, and that'll determine how many pizzas I sell. Well, if I increase the price by $2, I decrease the number of pizzas by 5. So the slope is -5/2. And the coordinate point says if I sell at $10, I sell 100 pizzas. So my initial point, x0, y0, is going to be 10, comma 100. And now I can build my equation. Graphically, it'd be tough though, because the points and the slope, those numbers are going to make it hard to visualize. But I can definitely do my equation, y equals m times x minus x naught plus y naught. Remember, this y is a variable. This m is, or sorry, the x is a variable. And the x naught and the y naught are the coordinate point. And then, of course, m is the slope. So I get y equals minus 5 halves times x, and then I subtract 10 from the x, and at the end I add 100. And that's the equation. This equation can tell me, once I pick the price, how many pizzas am I going to sell? All right, so I would choose x, and this tells me y. Or to put it back in context, if I charge X dollars, I sell Y pizzas. So let's try that. Let's suppose that I sell for $12. So my formula would say Y equals minus 5 halves times 12 minus 10 plus 100. I do the 12 minus 10 first because it's in the parentheses. 12 minus 10 is 2. And then I do the multiplication first because of PEMDAS. And I get minus 5 over 2 times 2. The 2's cancel, and I get minus 5 plus 100, which is 95 pizzas. And sure enough, that's 5 fewer pizzas. I charged $2 more, and I sold 5 fewer pizzas. Put units on there. All right. So what if you don't have any slope at all? How do I graph a function if I don't even have a slope? Well, when we didn't have a y-intercept, we needed an extra point. So if I don't have a slope either, I need 2 points, 2 coordinate points. All right, each has an x and a y. So let's take it as an example. A line goes through, and this is going to look familiar because we've been doing this before. 1, 3, and 5, -7. So I just graph that. I draw myself some axes. There's the point 1, comma 3. 1, 2, 3, 4, 5. -1, 2, 3, 4, 5, 6, 7. And here's the point 5, -7. And since it's a straight line, I can just connect them. And there I've graphed it. Now this equation, it does have a y-intercept. I just don't know what it is. It also has a slope because the slope is the rise over run. And actually, that's pretty easy to figure out. And this is something we did in a previous video. We build ourselves a table with our 2 points, 1 and 3, 5 and -7. The x value goes up 4, the y value goes down 10, because you count down by 10 to get from 3 to -7. So the slope is -10 over 4. I didn't mean for it to be the exact same slope as the previous example, but it is. The slope is -5 over 2. Now, if I want a formula, I need the slope and either the y-intercept. This allows me to do y equals mx plus b, or the slope and any other point. That will allow me to do y equals m times x minus x naught plus y naught. Now, I recommend generally go ahead and find out the y-intercept. Makes the things easier to use. And the way you do that is you say, I know that y equals mx plus b. And I know that m is minus 5 over 2 times x, or sorry, minus 5 over 2. So now I've filled in part of my information. I'm still looking for b. So I'll use my other information. And that other information is the fact that one of my points, x0, y0, is the point 1, comma 3. And that means 1 and 3 must make this equation true. If I put 1 in for x, once I do the equation, I have to get 3 out of it. And now I can solve for b. I have a whole bunch of numbers and a b, so I can now solve this equation and find out what b is. Minus 5 halves times 1 is still minus 5 halves. Solving for b, I add 5 halves to both sides. 3 plus 5 halves, well, I need to convert the 3 into something with the same denominator. So how about 6 halves plus 5 halves, which is 11 over 2, and that's what b equals. So now I started with my formula without any information. I got some information, I got the slope, and then I used the other pieces that I know about to solve for b, which was my missing piece of information, and now I can write down my formula with all the pieces. This is slope-intercept form. I generally recommend trying to get slope-intercept form. It's not too much work. You get the slope, you plug in an extra point, and you solve for the b value. However, this chapter, or this section, gives you a different way. So suppose I know 1, 3, and 5, negative 7 are on the line, same as the previous page. And from that, I find out the slope is minus 5 halves. I can use a point in the point slope formula. Let's try it. I'm going to remind myself what my point slope formula is. The y and the x are variables, and so I need to fill in the m, the x naught, and the y naught. Well, I know m is minus 5 halves. And I know I have the point 1, comma 3. So x naught could be 1 and y naught could be 3, and I'm done. So this is the equation. I can use this with any x value, and I'll find the correct y value. It's just that, well, graphing it can be a little more complicated, and using it can be a little more complicated. The point slope formula and this slope intercept formula, these are the exact same equations. But I think the slope intercept formula is a little easier to use. And so I think it's worth actually getting the slope intercept formula if you need a formula for your equation. All right, that wraps up this video. Thanks for watching.